Good morning. In this video, we are going to study about corrosion concept from surface engineering subject. I am David, Department of Mechanical Engineering, Rohini College of Engineering and Technology. A large number of corrosion monitoring techniques are available, but mainly these are the following corrosion monitoring techniques we are using, that is corrosion coupons, electrical resistance, linear polarization resistance, galvanic, hydrogen penetration, microbial, sand erosion technique. So this is the first corrosion monitoring technique we are going to learn, that is corrosion coupons. The weight loss technique is the best known and simplest of all corrosion monitoring techniques. The method involves exposing a specimen of material to a process environment for a given duration, then removing a specimen for analysis. The basic measurement which is determined from corrosion coupon is weight loss. The weight loss taking place over the period of exposure being expressed as corrosion rate. This is the second method of monitoring technique, that is electrical resistance monitoring. Electrical resistance probes can be thought of as electronic corrosion coupons. Like coupons, ER probes provide a basic measurement of metal loss, but unlike coupons, the value of metal loss can be measured at any time as frequently as required, while the probe is in situ and permanently exposed to the process stream. So example, in this diagram, a standard electrical resistance instrument is connected to a wire loop element which has a useful life of 10 mils. So initially, the instrument still read 0 because the element is new. So day by day, it will be reduced. Next monitoring technique is linear polarization resistance monitoring. The LPR technique is based on complex electrochemical theory. For purposes of industrial measurement applications, it is simplified to a very basic concept. In fundamental terms, a small voltage is applied to an electrode in solution. The current needed to maintain a specific voltage shift is directly related to the corrosion on the surface of the electrode in the solution. By measuring the current, the corrosion rate can be derived. The next monitoring technique is galvanic monitoring. The galvanic monitoring technique is also known as zero resistance ammetry. Is another electrochemical measuring technique. With the ZRA probes, two electrodes of dissimilar metals are exposed to the process fluid. When immersed in a solution, the natural voltage difference exists between electrodes. The current generated due to the potential difference relates to the rate of corrosion which is occurring on the more active of the electrode couple. The galvanic monitoring is applicable for the following electrode couples: bimetallic corrosion, crevice and pitting attack, corrosion assisted cracking, corrosion by highly oxidizing species, weld decay. Next monitoring technique is biological monitoring. The biological monitoring and analysis generally seeks to identify the presence of sulfate reducing bacteria. This is a class of anaerobic bacteria which consume sulfate from the process stream and generates sulfuric acid, a corrosive which attacks production plants materials. Then sand or erosion monitoring. These are devices which are designed to measure erosion in a flowing system. They find wide applications in oil and gas production systems where particulate matter is present. The next type of monitoring is hydrogen penetration monitoring. In acidic process environments, hydrogen is a byproduct of the corrosion reaction. Hydrogen generated in such a reaction can be absorbed by steel, particularly when traces of sulfide or cyanide are present. This may lead to hydrogen induced failure by one or more of several mechanisms. The concept of hydrogen probes is to detect the amount of hydrogen permeating through the steel by mechanical or electrochemical measurement, and to use this as a qualitative indication of corrosion rate. Thank you.